Hey everybody. Today we're talking about the average rate of change of a function. The average rate of change of a function, f of x, on an interval from a to b is defined to be the total change of the function over that interval divided by the width of the interval. In symbols, f of b minus f of a over b minus a, the change in the y values divided by the change in the x values. Graphically, the average rate of change is just the slope of the line connecting the points on the graph at x equals a and x equals b, as I've illustrated here. Let's actually carry out this example. Here we're using a as -2 and b as 4 and trying to get the average rate of change over that interval. So I do f of b minus f of a over b minus a. Then I see that f of 4 is 2 because of the point 4, 2 on the graph. And f of -2 is -1 because at x equals -2 on this graph, y is -1. I simplify a little bit and I get 1/2. That's the average rate of change of this function over the interval to -2, 4. Notice that the slope of the dotted line that I've drawn connecting those 2 points is 1/2. Let's do another example. Find the average rate of change of this function, (x² plus 4x minus 3, on the interval 2, 5. We use the same formula, g of b minus g of a over b minus a, the change in the y values divided by the change in the x values. Then we plug 5 and 2 into the formula for g of x, simplify, and we get -9, the average rate of change of g of x from 2 to 5. One other interpretation here. On average, as x increases over the interval 2, 5, for every unit it increases, the y value is going to decrease by 9 units. Now this formula, f of b minus f of a over b minus a, is convenient and very common in pre-calculus. But by the time you get to calculus, it becomes less useful. Typically, we let h be the width of the interval, so it's equal to b minus a. That'll simplify the denominator. We can also simplify the numerator a little bit. Since b minus a is equal to h, b is equal to a plus h. Overall, the formula for the average rate of change of a function over an interval starting at a and having width h is going to be f of a plus h minus f of a all over h. Let's go back to that function g of x from a few slides ago and use this new perspective to calculate some rates of change. We're going to be interested in the interval starting at x equals 1, so that's our a value, and having width h. So we're going to use that formula we saw in the previous slide, g of a plus h minus g of a all over h. By the way, that still represents the change in the y values divided by the change in the x values over this interval. Now we plug 1 plus h in to g, and we plug 1 into g. We simplify by distributing there in the first bracket, doing the 1 plus h squared and the 4 times 1 plus h. Combine like terms, and then the numerator becomes 2h minus h squared. There's a common factor of h in the numerator that we can cancel out and factor. So the average rate of change of g of x on the interval from 1 to 1 plus h is going to be 2 minus h for any h value. This can be very convenient because now we can just plug in different values of h here at the end. For instance, if we want an interval of width h equals 0.5, so the interval goes from 1 to 1.5, we get 2 minus 0.5, or 1.5 for our average rate of change. If we use h equals 0.1, so the interval goes from 1 to 1.1, then the average rate of change is 2 minus 0.1, or 1.9. So we can do the average rate of change over the interval 1, 1 plus h for any value of h very easily now.